You have seen how rocks are made and mountains formed, and also how and worn away. The crumbling of rocks is largely a mechanical process. There is also a chemical process that destroys the solid rocks. This is called decomposition. Decompose rocks by the chemical action of acids in water. Here is a piece of rock over which strong acid is running. Part of the rock is dissolved and carried away in solution. This is just what happens in nature, only more slowly. Rainwater soon becomes a weak acid as it trickles through decaying vegetable matter in the soil. See how rainwater flowing over these rocks has dissolved grooves in them. The queer shape of this rock is caused by chemical decomposition together with mechanical crumbling. In fact, these two processes always help each other. Certain materials dissolve more quickly than others. Thus, the parts which were decomposed first have left the holes in this rock. Rainwater is nearly everywhere present in pores and cracks a few feet below the surface, and at some places it flows out from underground in springs. You can find springs trickling out from crevices in solid rocks, or in sandy soil see the water bubbling up under the surface of a pool. Rainwater often seeps far underground. In this diagram, you see how it can work its way down along cracks and joints in limestone. The water dissolves the rock until, at last, it has formed a great cave. There are innumerable such caves. Here you are looking up from inside at the entrance to the world's largest cave. Down below are miles of enormous rooms and passageways. From the ceilings of these rooms, like icicles, hang points of rock. Water seeps down from far above, carrying dissolved rock in solution. As it drips into the cave, it evaporates, leaving deposits on ceiling and floor, and in thousands of years it gradually builds up these columns. Occasionally, underground water dissolves so much rock out of a cave that the roof falls in, making big holes in the ground. These are called sinkholes and usually fill with water. This sinkhole was probably once a cave. It may be hundreds of feet to the bottom. Another process that wears away and also builds up the land is the work of glaciers. Glaciers are large masses of ice that move over the earth. 30,000 years ago, much of the North American continent was buried beneath ice. One ice sheet formed in the northwest. This was joined by a second, and later by a third. A fourth spread over Greenland. Thousands of years were required for the ice to creep over all this country. Then, taking more thousands of years, it receded, until only the great continental glacier on Greenland was left. This still remains, and today you can see parts of its edge advancing into the ocean. As it moves forward into deeper water, huge pieces break off with a terrific noise. Often the pieces are bigger than an ocean liner. Each year, many blocks of this glacial ice float far out to sea and are called icebergs. As well as continental ice sheets, there are smaller glaciers. In high mountains, the snow does not all melt away. If enough snow collects at the head of a valley, it changes into ice, and the whole mass creeps down the valley. As it moves, it picks up loose rocks, tears away parts of the hillside, and carries the fragments along. Some parts of the ice move faster than others. In this model, the action is speeded up so that you can see how the uneven movement causes cracks to develop. This makes the surface very rough. Sometimes great open chasms like this appear where the glacier moves over uneven ground. The loose rocks and material that are frozen into a glacier are deposited where the ice melts. Notice all the stones and dirt once frozen in the ice. The glacier that was once in this valley has melted away, leaving these piles of stones and boulders. They are called moraines. Grass and trees may have grown over the moraines, but underneath you can see the boulders and pebbles and dirt a glacier carried here. You can imagine how these boulders scraped away the land when the ice pushed them along. At places the solid rock of the Earth's crust has been gouged out in long straight grooves by material carried in a large glacier. The appearance of whole countrysides has been changed in this manner. Moraines and stony soil have been deposited. Hills and high places have been rounded off into rolling country. Thus you have seen how the power of moving ice destroys and also builds up the land. Another important earth-wearing force is the wind. On mountain tops, strong winds frequently drive the snow and clouds about with great power. Little vegetation can grow on these high places. Trees become twisted and bent. This tree is still alive, but the winds kept it from growing upright and have blown away all the bark. The force of wind is best shown in the sand hills of deserts and on shores of lakes and oceans. As rock is decomposed and crumbles away to sand, the wind picks up the sand and sweeps it into great piles called dunes. These sand dunes constantly shift about. Their surface is marked with small ridges called ripple marks. As the sand blows, it may cover shrubs and grasses. Even whole forests have been completely covered by an advancing sand dune, only to be uncovered again when the sand moves on. The trunks of these trees are all that is left of a forest that once grew here. Blowing sand, when it beats against solid objects, scratches and polishes them. Steadily it gnaws away the hard rock. Yet what the wind destroys in one place, it builds up elsewhere. There is still another great force that builds up and wears away the land. This can be seen along the shore of the ocean, where waves eat away parts of the coast and change the shorelines. Rocky ledges and cliffs are worn away. Under the terrific impact of the pounding waves, the joints gradually weaken. The swirling waters carry away the broken rocks, rounding them into boulders, splitting and grinding them into pebbles, finally powdering them into sand. The hardest rock cannot forever withstand the force of waves like these, and whole coastlines are changed as the land is worn away. A good example of this is an island in the North Sea, which has almost disappeared in the memory of man as the waves attacked it. In 800 A.D., the distance around the island was 120 miles. By 1300, it measured only 45 miles. By 1649, it was 8 miles, and by 1900, it was a small cliff of rock only 3 miles around. Where the land has recently risen, or the level of the sea has been lowered, you can sometimes see the rocky floor of the ocean. Where the coast has sunk, the sea will reach farther up into the low parts of the land, forming long, narrow bays and inlets. Low places in the land then become sea bottom, and the higher places appear above the water's surface in long ridges of rock or as islands. The force of the sea breaks some parts of the coast into boulders. These are gradually pounded into pebbles and sand as waves wash them back and forth. Some parts of the coast are thus built up by material worn away elsewhere. Coastlines are always changing. The force of the waves cuts them into an irregular outline of rugged headlands, rocky islands, and gently curved bays and beaches. Yet not even the dashing of all the oceans on all the sea coasts in the world, nor the blasts of the strongest wind, nor even the gouging and scraping of the largest continental ice sheets and glaciers, nor the dissolving of rock by chemical decomposition, and not even the mechanical crumbling of rock into soil, none of these things, nor all of them together, equals the power of running water. This great force of running water will be the subject of our next study.